when I kept referring to a vector, I kept mentioning, well, what magnitude is for direction. I, J, K unit vectors will determine the direction, but what is the magnitude? Suppose if I have a vector V, which is A, B. Good. And in terms of the unit vectors, what would that be? True. It's just I. How would you write it in terms of
A over 0 plus 0 over B.
A over 0?
Like A 0 and then plus 0B.
Okay, we'll have A 0, 0, B, right. Just like the previous problem, we had negative I vector, that's 4j vector, 4j minus 2k. So I want you to write A, B in terms of I, j. What would it be?
So AI plus BJ.
A, I vector, plus B, j. Both of them wins. But the magnitude of the vector B two bars and then vertical bars B followed by two vertical bars. Upper level magnitude we also call it as the norm of a vector. In this case, specifically, we are talking about a two-norm. Too much information. The magnitude of a vector is simply the square root of each component squared and summed. So I have component A, so A squared, plus B squared. Good. Let's find the magnitude of the vector. Or you can try based on what I've provided you. Find the magnitude Good. Give it a try. I've used two different notations so that you get used to them. So I'll call this vector U. I want to find the magnitude of vector U. That is the notation. Square root. Component, 3 squared. Second component, 4 squared. 9 plus 16. Square root is 25. 5. Magnitude is always positive. We don't look at the negative value. I'll call this vector B. Just as a reference, if you want to write it in terms of the unit vector, you can write it as negative 9 I vector plus 2 J vector, one and the same. The magnitude mean all three. What is important? The negative and I advocate this a lot. Parentheses. Negative 9 squared plus 2 squared. 81 plus 4 square root of 85. Approximately 9.2 something. Are we clear? Okay. So we found the magnitude, and I mentioned, well, we write vector notation so that we can have magnitude in this direction. We haven't got into the direction, but I just want you to connect the dots. So basic erase this guys. I want you to find the magnitude of unit vectors in 2 dimensions. Then 3 dimensions. You should know what the unit vectors are in 2 dimensions. You should know what the unit vectors are in 3 dimensions. So, what are the magnitudes? So, we want to find the magnitude of unit vectors. So, first, what are the unit vectors in 2 dimensions?
1, 0 for vector I, 0, 1 for J.
I vector would simply be 1, 0. Yes. J vector 0, 1. Good. The problem many of you had is because of that part. If you try to rewrite 1, 0, you would end up back where you started. Yes, do you agree? 1 times I vector, 0 times J vector, I vector. We keep going in circles. What we want to find is the magnitude of that. Good. Magnitude of the unit vector I. This problem right here, I was able to go from here to there because that's not a unit vector. Good. -9, 2 would correspond to A, B there, and I got the magnitude. If I want to find the magnitude of the unit vector, looking at it this way, it's easy. What is the value of A? Riley, can you hear? She said something. She said 1. So she didn't. No, she said negative 1. You actually said that. He's just making stuff up now. So A is 1 and B is 0. So the magnitude is 1 squared plus 0 squared, which is square root of 1, you get 1. Good. Most common mistake when you find the magnitude, you are more likely to do that. Do that. Right? The letter I, the arrow indicates that. Good. So you can't put it as I vector squared or j vector squared. So don't make that mistake. Even here, did I use I and j inside the square root? I did not. All I looked at was the number. Oh, here. J vector. Square root. What is the value of A? For a J vector? 0. What is the value of B? 1. Square root of 1. I get 1. Good. This is what I meant by connected points. If I extend this idea to 3 dimensions, I vector simply be 1, 0, 0. J vector 0, 1, 0. K vector 0, 0, 1. Good. If I asked you, well, find the magnitude of I vector, where does your mind go to? Listen. True, how did you get that? I'm not even going to ask Friday because he's just going to give you the answer.
1 squared, 0 squared.
Okay. All Elisa did is extended this idea and simply squared the individual components, summed them, took the square root. 1 squared, 0 squared, 0 squared, square root of 1, you get 1. Good. Magnitude of J vector. Do we have to write that? If we did, what would it be? Come on, Sky. Square root of. No. 0 squared. What's 1 squared? Which is 1. Do we get that 1? And naturally, we follow the same process, you will get 1. Earlier, I was talking about unit vectors and I asked you, why? Well, because you've got a 1 there, 0, 0 there, 1. But the most formal way of explaining a unit vector is that the magnitude has to be 1. Okay. So we call vector I, vector j as unit vectors because their magnitudes are 1. Good. With me? With these two, sure, I can say, oh, you see a 1 there, you see a 1 there. Hence, it's a unit vector. But not always true. There are other vectors which don't look like these two, but we call them as unit vectors because the magnitude is 1. So formally speaking, a unit vector is a vector that has a magnitude of 1. Rita, can you hear me? Great.
Yeah. She's
Wait.
everyone.
No, she.
I'm not going
Hey, escape anymore. Are we clear?